3 SCHC working group. This is an official IETF meeting. So I guess by now you're quite aware of our usual not well. So be aware that we have a strong code of conduct at the IETF, and the BCP that are listed here explain what is expected from you. If you're a victim of some form of harassment, there is an ombuds team that you can contact and work with them to solve the issue. And as usual, we've got BCP 79 about patents. So if you're aware of IPR that has not been disclosed and that's being discussed today, please let the chairs or mention it on the mic. Please let the chair know or mention it on the mic, or refrain at all from discussing this IPR. Well, I guess you've seen that a number of times. I can let it a little bit just in case. Otherwise, you can review the slides or come back to the chairs if you have an issue with harassment or anything like that. So there is an in-person meeting tool. This tool is available on phones, PCs, etc. And there is a link on our agenda. So I guess you know about the tool. Please use it to register to the session. That's how the blue sheets are being built. So please register if I need to do that. You will also need this tool to go on the mic if you want to talk over the mic. And as usual, we've got the resources. I guess you know them by now. Okay, so we have a pretty deep agenda, so I'll take care about people not going beyond their allocated time. So please be respectful to the people coming next and try to remain on your side on your time. Otherwise, you will see me waving at you and saying, hey, I've got to move on. So we'll spend 20 minutes on the architecture to give you the status of what we're doing there and how it's moving. Then we'll have Marco. So Marco is working on the update of the SCHC for co-op document. Then we'll have Alexander talking to us about the interaction between this group and the tip-top working group, which is tomorrow. And then Alex will stay on the mic for the SCHClet model. So that's where, Alex, I'll be there if you spend more than 10 minutes. Then we'll have Laurent about seed allocation and core conf. It's really two issues, 2 items, but it's 10 minutes for both of them. So Laurent will have to manage how he uses his 10 minutes. And then 2 very interesting pieces of work which leverage SCHC. We'll have Amina presenting an architecture, a model on how we can use SCHC in a 5G core network. And then we'll have Manoj talking about his work on geo-networking, leveraging SCHC. Okay?
Just for the agenda bashing, so yesterday in the ANRW workshop, there was Mariam that presented a work on SCHC 0, so applying SCHC to ND and other stuff. So if we have time at the end, like we'll have a minute for that, a minute or 2. So we hope that we'll have time for that.
So Mariam, when you see AOB, that's you basically. So any question about this agenda? Any change you want to make? Okay, so let's move on. So the new work that was published is mostly the new update by Marco on the SCHC for co-op. So Marco will be explaining that to us. Then there is this topic about protocol numbers, and I think Bob said he would be with us. He's online. Okay, so Bob, we hope you're there and we'll need you. And apart from that, nothing really interesting mentioning. So here is, we have a lot of personal submissions, so I made them a separate list. I don't know exactly which ones are expected to move as workgroup documents and which ones are more documenting problems. So we'll see how it goes. Just a quick mention that we have a MOOC that is work in progress by Laurent. So if you're interested, please click on this slide and visit our MOOC. So it's improving by the day. And right away, we need this discussion on the SCHC protocol number. So it's a document that was started long time ago with the idea that we could reserve a number for the ether types that we would work with IEEE to get in the IEEE INR. We also want a protocol number from IP and IPv6. And the idea was to request a port number from UDP. And with an early document, we went on and asked for early reviews, and we got reviews by TSV Art and India, which really pointed out that the idea of requesting a UDP port was probably a bad idea, that the port should be negotiated and not assigned from the first 1024 ports. So with this, the idea for the next version of this document is to remove all the discussion about UDP port numbers because it's going to be very hard to get a consensus on that and focus on the ether type and the protocol number for IP. Then I tried to contact Bob to see how we edit this document. And Bob, if you're here, I mean, you need to tell us if you want to move on with this document or if you want to hand it over to somebody else. Bob?
Yeah, I'm sorry for my disengagement. I'll be getting back with this. I'm perfectly happy to drop the UDP part. That was your work, not mine.
Bob, I don't think the room could hear you. Initially, it was very strong and very good, and then we just lost your voice. So did you move versus your mic? Or can you please repeat?
Can you hear me now?
I think yes.
Sorry about that. Yes, I will be re-engaging on this work. I'm sorry for being away elsewhere. Been having fun with satellite stuff, but now I'll be back on this item.
Okay, so let's exchange on the mailing list but basically we need to publish as soon as we can a new version of the document so we can really ask for those protocol numbers.
Can I add just something? So there was a use case for the UDP port coming from Carlos. So Carlos excused for not being able to be here because he has a conflict of the working group. So probably before removing that, like, I don't know, just double check with him about his use case, if that is still a valid request or not. Right.
And I recently reposted on the mailing list the comments by Joe Touch and Mirya. Before asking for anything, please consider their comments and the reasons why they were opposed to the idea of asking for a UDP port. And probably the answer of why not do it is already there on the mailing list. Okay. So with this, we're going to move to the architecture discussion.
Eric Vink, just to check, do we have a minute taker to take note of the actions?
So I'm taking some of the minutes and Marion as well. Thank you, Marion.
So this is a quick discussion on the progress of the SCHC architecture. First thing is, I want to share with you to make sure we all agree on what the process is for this document. The idea of this document is to communicate, to store for the working group the progress of the way we are seeing how we do things at SCHC. Meaning that the idea is not to complete the SCHC architecture and then start the work. The idea is to have the work being done on several documents, including 15.4, including COAP, PPP, whatever, and see from those documents what SCHC really needs to do, and get a consensus on the working group on each of those things that SCHC needs to do. And once this consensus is reached, write it down in the architecture so we have a repository of what we have agreed upon. And when it's written, obviously, people read it and comment, oh, that's not what I understood, etc., till we really reach consensus on things. And consensus by consensus, we end up building a document that we need to restructure, etc., until we have the full architecture. And probably we'll only get this full architecture once the working group concludes. So please do not expect the architecture to be complete, the architecture to be fully correct. We are still working on the terminology, which is probably the first thing we really need to really complete. And then every item like how you do provisioning, how you structure a packet with the SCHC stratum, which was recently introduced, etc. All this is being built as we go with the work of this working group. Okay, so that's really the mind of for the architecture. It stores the current consensus, and what's not there, it's not because it does not exist, it's because we still need to reach a consensus on this. What we do at SCHC compared to what we did at LP1 is really expand the use of the SCHC protocol to any kind of environment that we wish to support. It could be deep space with TipTop, it could be PPP, it's one of the first examples that came up of where we would like to use SCHC. And that's when we realized that a lot of what we did for LP1 was completely implicit, but to generalize the use of SCHC, we would need to have more stuff explicit. And so discovering what this stuff is, discovering how we encode it, how we share it, how we publish it, how we synchronize it between the peers, how we structure the peers. Is it just peer-to-peer, peer-to-multi-point to multi-point, multi-point to multi-point? All this we are discovering as we go. And one big aspect of that is how SCHC interact with the IP stack, or with the stack in general, because SCHC now is no more just IP. So we used to talk about a SCHC packet, for instance, because 8724 was about compressing IP, but now we need to talk about SCHC datagrams because we just compress a set of bits, which could be a portion of the packet. That's what they do for IPsec. So in the art, and we still need to support that model, the art of LP1, basically the stack was a purpose-built stack with SCHC in the middle somewhere. So the code path really at some point would branch to SCHC, SCHC would do its stuff, and when SCHC was done, the code would branch again back to the stack. It just was part of the stack. If you don't have a rule to tell you what to do, then there is only one processing possible, which is again what IPsec does. Otherwise, there would be multiple rules which would tell you, you do this or that. But anyway, you would always go through the SCHC code. This is why, by the way, in RFC 8724, you must have a rule which is no operation. Because for everything that SCHC doesn't understand, you still go through the SCHC code. So you need to tell SCHC, don't do anything on that packet. There is nothing you can understand. Just move on along those arrows. Okay? So that's where this requirement for having a no operation SCHC rule came from. Now, when you generalize that model, it means that you have a stack that comes from any place, and you need to insert SCHC in that stack. To insert SCHC in that stack, you don't want to do as you did earlier, that is modify the stack and put hard code, a code point somewhere in the code to just branch SCHC and back. The way you want to organize that is use somewhere in the stack where you already have a dispatching point. It could be an ether type, it could be an IP protocol type, it could be a UDP port, it could be other places in the code where it already branches, and add to the list that instead of branching to FTP or branching to whatever the protocol is based on that port, you could also have SCHC. So register SCHC as one of the possibilities for this particular dispatching point. And when that happens, SCHC will have to rewrite the portion of code which said, oh, it's SCHC, because otherwise you would loop. So basically, you need to change the port number or the ether type or whatever it is you're branching on. You need to swap it with the SCHC code to restore the value that was supposedly there and come back to the dispatch that just called you in the stack, so the stack may continue. You see? So it's a very different model from the original IP1 model, but that's the way we can insert SCHC in the stack. And because we depend on existing dispatch types, that's why we need to have those ether types, to have those ports, to have all those things. Okay, it really comes from this loop in the stack model. Okay, and then can you bring?
Yes, I'll change the slides.
First, kill that. Yes. There. Coming to terms. Okay, so we had a side meeting on Monday, and the main purpose on that side meeting was first to agree, like we just do now, on what's the purpose and how we work on this architecture document. But we also saw, and as we all know, that the first thing you need to agree upon before you can start any work is have a clear terminology. And we're working on our terminology. It's non-obvious, right? We're agreeing on terms that are simple enough, that everybody agrees upon, very difficult. So we're still in that process, and we tried during this meeting to progress. It could take the 2 hours today just to agree on something. So we won't do that. We don't have that time. So I just want to show you where we were, what we saw during that meeting, and then we'll move on the mailing list to continue that discussion. So the first thing, as I already mentioned, is the concept of SCHC packet. People are used to talk about the SCHC packet, but packet, the term packet is really something that refers to a layer 3 operation. A packet is an IP packet. Okay, since SCHC operates on a bit stream, on any range of bits from here to here in a packet, or even something in memory, if you want to SCHC compress an image, maybe you can. You can't use the term packet for talking about this set of bits that SCHC is looking at. So we kind of propose to use the term datagram, but this is kind of open. We still need to name this bit field upon which SCHC is operating and not use packet. By the way, we always use the term SCHC header, but it appears that it's not documented anywhere in our RFCs. What we have today in our RFCs is compressed header or fragment header. So compressed header is when you have rule and residue. Fragment header is when you have the fragment operation. It might be that we define new SCHC operations, which will be neither a compressed header nor a fragment header. But we are missing the term SCHC header. We have not defined it to say it's any of those things. So we still need a term that says it's any of those things. But when we talk, we always say SCHC header.
So if I can add just something to that, and it is, as we were discussing, like in the LP1 working group, we were working, and a lot of the things were implicit. So a lot of the things were simpler because they were in our heads, right? And now when we're making everything explicit, this is where we're like, oh, okay, we didn't define this exactly, and this is where we want to really put the right terms so that it speaks to everyone, right? And that was really an excellent work of the side meeting. So there were about 15 people there, and we really got to a place where like everyone, I think, was on the same page of understanding the problems of, like, we cannot just like, it's difficult to say what is the SCHC header. People understand that differently when you say SCHC header. So I think this is where we made a great progress about having that awareness of, okay, well, we cannot just name things like this. And this is where I think we had very interesting specific proposals.
So basically, we need to bring back more terminology from the existing RFCs and see, for instance, if we really need this term SCHC header that we use all the time to cover all the types of compressed header, fragment header, etc. As we do this architecture, we realize that part of the implicit information is something that should be on the wire to, for instance, an instance ID that will allow you to define which of the instances running in this device for that stratum will be used for this particular packet. There are a number of informations like this which were never needed on LP1, but will be needed to dispatch and process a SCHC packet in the general case. Another example is if you look at this branching that I discussed with the dispatch, there is a value in the packet when it flies compressed that says SCHC, but when you run SCHC, then you need to replace it by something else. And it might be that this something else is actually part of the residue of the compression, but it's not something which is really the residue of the payload. It's something which is meant for SCHC operation. So it's really the straight stratum control data that we are talking about, not the user payload, if you like. So we realized that we really have two SCHC headers back to back at the beginning of the packet. The SCHC header, as you're used to for LoRa, that will maybe do fragmentation, or that may be doing either compression, and another SCHC header which really deals with the SCHC control data itself, that will completely go away once you have expanded SCHC, but that is needed to do the SCHC expansion. So you could say, oh, but let's build rules which have the two of them the same, but that would kind of multiply the possibility of rules. It's much better to have a compression for the SCHC piece, which depends on SCHC, and the compression of the protocol thing, which depends on that protocol, as opposed to moving them in the same set of rules. That's why we have those two SCHC headers back to back. And the question was, how do we call those things? So right now we have those terms in the architecture. The first SCHC header is called the SCHC stratum header, and the second SCHC header is called the SCHC payload, and the term header was missing. It's my fault. And then for the rest of the bits that we're not touching, we would, in this strata, we would call that user payload. People are not satisfied with that. I can understand why. And there was this proposal to use SCHC control header, SCHC data header, and just payload, which is on the right. And to which I wrote that if it's a SCHC header that's for control, then in English, it's probably more a control SCHC header than the SCHC control header, blah, blah. So I'm just presenting what we discussed. We can have like 2 words on that, but we can't talk too much about terminology right now, right? We can't define terminology here. We don't have.
No, just one point is that I like control. I don't like data, because the data, in fact, is the header we are compressing. So I think a SCHC header, just for that, and you have the control SCHC header, and the SCHC header will be enough. But data introduce confusion on what we are compressing.
Okay, well noted, but I won't start a discussion on that. So please go to the mailing list. And we have all the track of that discussion on the mailing list. But basically, that's where we are. Then there is the work. There is a new document, actually, that was published too late. I think Quentin published it during the IETF, but not before when we were preparing for this IETF. So he missed the date. And in this document, he realizes that we're also missing a word for kind of explaining, detailing a set of devices which could talk together, or a set of devices which has this property. For instance, same administrative domain, devices that will be administered by the same thing, so you can set up the same SCHC rules in them or something like that. Devices which participate to the same instance at the same time, because we realize we don't only have point-to-point, we have point-to-multipoint and multipoint to multipoint instances. How do you call the devices which participate to that particular instance? And actually, how you call the devices which could be configured to participate in an instance that can join one another and that is the same software or enough common administration, so you can reset up a SCHC instance between those two devices, or those two endpoints, really. So the term domain seems to be appropriate, but it's, and maybe there is more than one type of domain, because one is about instance participation, one is about who is being administered, but they might be in the same or not the same instance, and one is about capability to operate at a certain stratum. So for instance, like when you compress IP and decompress IP, you're at the same stratum. But if one is doing CoAP and one is doing IP, they cannot be in the same stratum. They're not dispatched at the same place, so they can never talk, right? And CoAP would be in the end device, and probably the IP compression would be somewhere in the network. It's not even the same physical device possibly doing that. So we see that we need to be able to say, hey, this group of device on which I can do this, or this group of device which does that, and we probably need to define a name for these groups, and it's probably based on domain. And that's pretty much all I had. Just a little kudos for the work that's done on 802.15.4. And part of what's happening, it was just presented at 6LOW, part of what's happening there is the realization that you need an instance on which every device on a domain really participate, just to do a compression of a protocol like IP over 15.4. And when you do that, this instance is completely stateless, completely RESTful, meaning that the packet comes in, is uncompressed, and comes out. But there is no state left after the passing of this packet, which is different from all the type of instances we currently have in the architecture. In the architecture, everything we have is stateful. Think fragmentation, you need to remember in which state you are with regard to fragmentation with that device that you're talking to. So in point-to-point LP1, that's what we had. We were stateful on both sides. We knew where we were. We already introduced for DLMS the concept of point to multi-point. You can still fragment, but there is a single source and it's stateful on every device. Now, because of the work on 15.4, we realize we need to have a new form of instance, which is stateless. It cannot do fragmentation, but it can do protocol expansion if it's completely stateless. You can receive a packet from anywhere, uncompress it, pass it up the stack, and forget. Meaning that it doesn't, because you don't have to keep a state, you can receive packets from anybody in your domain, uncompress and pass on. This type of processing we did not have in the architecture as it's written right now. We will need to include it. You know, this really illustrates how we want to work with the architecture. As we build SCHC over foo, we realized that, oh, we did not describe this type of operation in the architecture. We need to add it. Exactly what we're going to do for 15.4 in the next version of the architecture. Any question, remark?
I would like to add something to that. So I really love the way the work went during the side meeting, and I think it gets us much faster in the convergence of this SCHC architecture document, where a lot of the things are clear, but we really need to nail down the terms. So that I would really like that in our next, I don't know if it's going to be in the interim meetings or in the same way as side meetings, to have like 1.5-hour sessions where we really focus on working as a group to like finish all that, right? Because we have it now. We have it now, and we just need to, you know, to ship it. So that will be sometimes in September when we restart our interim meetings. Marco?
Hi everyone, this is Marco. This is an update back-to-back of the latest 2 revisions of this document on using SCHC for compressing CoAP headers. So as a quick recap, this document is intended to formally obsolete the current RFC 8824 for using SCHC to compress CoAP headers. It has quite a broad scope, but it's mostly about clarifications and things that could have been done before in 8824, and we are adding now. Clarifications are both general at a high level, also based on filed errata, and on concepts related to compressing the co-op options, or covering new co-op options or extended options since the publication of 8824. Also more clarification on other niche cases in compressing in co-op payloads. And the biggest part, I believe, is the third from the last that really triggered all this, considering explicitly the presence of proxies between origin endpoints and the compression of co-op headers with SCHC in that case. There's also a new IANA registry that helps further for extensibility of SCHC as co-op is extended, and well, a Young data model too. Starting from the update for version 3 to 4, so this was intended for Bangkok where SCHC didn't meet, added an obvious editorial improvement and some trivial updates to the references and the data model. Yeah, I noted that there was some consistency to be enforced pretty much editorially on the tables where we describe the example rules here. So that the field descriptors followed exactly and deterministically the order of fields in the message to be compressed. A single notation for indicating the same thing, I think in TV for the co-op message ID, following a recommendation from Karsten using abbreviation for units, appropriately following an ISO standard. I also tried my best to harmonize the phrasing about the same thing when it comes to a special function to somehow compute the size of a field from the value of another field, meaning TKL and OSC-XM. Now the phrasing should be harmonious between the two. There was a comment around Dublin, I think, from Quanten on essentially clarifying the rationale and the motivation behind the definition and the use of the TKL function, and I believe more in general, or similar functions like that we also have in the document. It's quite a long paragraph if you check the document, but I try to compress it here on its most relevant parts. And after defining that function, I think it's really about the final sentence. We're doing that just like 8824 already was doing so, to avoid ambiguity with sizes in the message, in the rule, on the wire with the residue, and bottom line to achieve a more efficient compression. So there's no change in the intention or the means, it's just an editorial clarification. Then what we also discussed in Dublin and was agreed was to define a new dedicated function that was not defined in 8824, but it's really the same principle of TKL that is just as well applicable to another field, or I should say subfield, partial IV in the OSCOR option when OSCOR is used. By the same principle, it's as simple as that. We have defined a new function OSC PIV that takes as input the last 3 bits of the flag subfield of the OSCOR option value, the green box basically, and out of that input it produces the size in bytes of the partial IV subfield in the red frame. So like you do for TKL, you can use OSC PIV in the field length field descriptor for the partial IV subfield of the OSCOR option, and that has the same benefits and consequences of using TKL for the token. Back to what I mentioned before that I started doing first with the examples, enforcing the strict order of field descriptors consistent with the order of the corresponding fields in the message is something that we have always taken for granted, that built the example more or less accordingly until now. I thought it was better to state that explicitly. So in practice, we really want the rules to have the field descriptors in a particular order that mirrors exactly the order of fields in the message. And well, for co-op headers, it practically means that. And when it comes to options, in turns, the field descriptors are supposed to follow the order of the options that are ordered per co-op by their co-op option numbers. And yeah, the examples of rules, of course, followed this sort of general clarification. And that was for the version intended from Bangkok. Now, building from that, we now have the latest version available in the data tracker today. A very important administrative point was taken care of. Thank you very much, Pascal. Now we have a Git repo under the control of the SCHC working group where the draft sources are living. I noted even one of the authors changed affiliation, so the contact information were also updated. Sure, minor rephrasing and editorial. I'll leave you to check with that with the diff, nothing major. On more substantial thing, of course, we are covering also the compression of the Oscar option. There has been some extension ongoing in the value of the Oscar option in another document in core. And more recently, the semantics of one of its subfields, X, has changed. Well, the text here has been revised accordingly. But in the process of working on the core document, 2 other subfields were actually removed, which meant I removed them from here, together with other things related to those, as to a dedicated function and entering Yang data model and so on. So once again, this is now aligned with what is happening for the extension of the Oscar option in the core working group. Very luckily, this had no impact and no need to revise the example of compressed messages here in the document, because we were considering those removed subfields as empty anyway, so no problem with that. Just as an editorial clarification, I prefer to add a paragraph describing what happens in terms of SCHC compression when not Oscar but group Oscar is used. Well, there's no real difference because SCHC still compresses the header, and the only practical difference when using group Oscar would be having a signature appended to the payload if the group mode of group Oscar is used. But SCHC doesn't care of the payload, so no practical change on the wire, or conceptually still it was worth the clarification, I think. In the process of doing that, I realized maybe it's better to be even more clear on how SCHC thinks of compressing co-op options, starting with an introduction on the structure of co-op options in the first place. Also considering the work that is now ongoing also in the SCHC universal option document. So I prefer to put that part of the document about compressing co-op options in that perspective, mention that there are in principle 2 possible approaches to take care of SCHC header fields, and in particular the options, the semantic and the syntactic approach, trying to give the intuition really in short, to not restate that other draft about the core philosophy of the 2 approaches. And then admittedly, all the content and the concrete examples in this document are really revolving around the semantic approach historically and currently. I believe that that's a good thing, but still now all approaches are on the surface and possible to use. Right. This was about also related to the latest development on the semantic or syntactic approach, and considering the semantic approach again. If you take that approach, the field identifier really needs to tell you what field you are talking about. So I try to come up with a sort of schema for the name of the field to use in the field identifier. And I think Laurent in the past month suggested something like that on some mailing list messages. I try to build on that. And it's essentially about, when it comes to co-op option, having the field ID saying, it's about co-op, it's about an option, it's about this option that can be authoritatively identified by its co-op option number that comes from a co-op option number registry. So you can have something like co-op.option3 for the URI host option that has a co-op option number 3. But we also have options with subfields like the Oscar option. In that case, well, just the same, you have to continue mentioning the explicit subfields. So you can have co-op option 9, meaning the Oscar option dot flags for its flags subfield that was also shown in the slide before. For consistency, a registry that we have to support fundamentally extensibility together with the coupling of defining new co-op options and defining way to compress those. The registry was updated so that the entries in the leftmost column are sorted by field appearance and option number, and they are using also this convention expected in the field ID of the rules. And I have one open point that I noted to confirm on the TKL function. Well, right now it's considering the semantics of the co-op header when it comes to the token field as per the original co-op RFC, and that is fine. But a few years ago, an RFC was published, 8974, that extends the co-op header. Well, like it happened already for the co-op option length and co-op delta extended. Depending on the exact value that you have in the TKL field, you are indicated either the exact size in bytes of the token, if that's between 0 and 12, or instead you are giving a hint to look forward in the header in between the message ID and the token, where you are going to find encoded in 8 or 16 bits the actual size of the token extended, and that can be very long. So right now, SCHC is not covering this, or better said, the TKL function is not covering this. So I think we should revisit the TKL function so that it considers as input, well, not only the TKL field, but the TKL field together with, if present, the TKL extended field. And based on the combination of those, the result is still, just like today, the size in byte of the token field. It should really be just about the definition of the TKL function to take an additional input. And I believe that requires also, in that respect, an update to the Yang data model. But hearing no objection or no one screaming, I think this is a good fix. Otherwise, we keep TKL locked to the original specification of co-op only. So I'll try to make this into the next version of the draft. And last thing, the errata. There are two open errata on this document. The first one was triple checked by Laurent, and it should be okay to be approved, as I understand. The second one triggered a bit more discussion that continued also until a few minutes before the session between me, Laurent, also, and Eric. And Laurent and I will follow up after lunch. The gist is that the essence of the erratum is correct, but to practically address it, we would need new text in RFC 8724, not because anything is wrong or incomplete there, but because something started there should have been clarified a bit better. Now, this is getting too complicated, so practically it's better to just reject this erratum and have new text only in this document, specifically in the interest of co-op compression, but in the interest of a general clarification for SCHC and 8724, we can have a paragraph that formally becomes an update to RFC 8724 from this document, not observation, update. Looked okay from early informal discussion before. So Laurent and I will discuss some tentative text in detail this afternoon, hopefully, and that can follow up already in the next revision. That's the plan, at least. And that is all I had. Thank you.
Thanks a lot, Marco. So any question? Nobody? Okay, so the next presenter will be Alex, and I will be preparing your speech.
So maybe I'll have a question to Marco. Sorry, about the state of the draft. When do you think that the work is going to be getting to some complete state where we can start thinking about closing it?
Hopefully 2 or 3 revisions more, I would say. So I hope somewhere next year. At some point, we need to be careful if having some particular text in this document or to some other document in core, because things are a bit moving on some particular parts. And we may want to keep the text in the latest expected document to get to the ISG.
Okay, yes.
But we are not there yet, but we'll approach that soon, I think.
Okay, thank you. Because that's also one of the things that at some point very soon we'll need to revise a little bit our milestones and try to set dates on when we ship the different documents, because the work is getting done and everything is really progressing. But just to say, okay, well, at that time, people should start reviewing that actively, right? So thanks. So thank you very much. So I'm going to have a very short presentation to talk about SCHC applicability to IP in deep space. So the meeting of the working group tip-top is actually tomorrow. So we were planning to actually have some feedback today, but this is just going to be like a presentation of the big picture of things we would like to present tomorrow. And thank you, Mark, for attending. So we have Marc Blanchet that is in the room, who is one of the important proponents of the technology for tip-top, right? So basically just a short recap of what are interplanetary communications. Of course, this is a very like high level summary and a little bit like a pitch to you. So the focus is on Earth to Moon communications, but then of course there is Earth to Moon, Earth to Mars, Moon to Mars, and if your imagination can go for, so that's not an official like of the tip-top working group, but this is where I am, the way I am seeing things, like any asteroid to any spaceship anywhere in a galaxy, right? So it's a very exciting and challenging way of looking at communications, right? But if we look at, oh, why don't I don't have a, okay, there is actually a graphic over there that doesn't show, so I'll need to fix that. So normally there is a like a planet here talking to a satellite that is talking to another satellite orbiting another planet, and the link on like with the interplanetary link. So the important, sorry. Yes, it's very yes. So the important point is that like the traffic characteristics are like, you can imagine like point-to-point links, and you can have like very long RTTs. Like to the moon, it's like 2.56 seconds, but it can be up to 45 minutes to Mars, and like it can be hours to other planets, right? And throughput can vary, but in any case, like it's a precious resource. Even in cases where you can imagine like megabits per second with some lasers or stuff, it's still a precious resource. And this is where SCHC can actually play a big part in our opinion. Like, so the tip-top working group meeting is tomorrow from 5 to 7. So please go and join there, you know, to get the discussion and the support. And the point is that today, like, you have a lot of several working group documents or documents that have been discussed about the requirements, like the characteristics of these links. So these are working group, like these are documents discussed at tip-top. And there are things like how you run DNS over these very like long RTT links. How do you do email? How is the addressing done? Like I read somewhere that I'm not sure that's going to be like the final architecture, but you can have like a single prefix for a planet, which would be really nice because you can have like a SCHC rule that compresses this prefix, and you get like a couple of bytes away of the air, right? So and of course, one of the things is that QUIC is one of the main protocols that is being studied for this kind of communication, right? And so, a very short pitch. So why is SCHC interesting for tip-top? Well, the first thing is like it's a framework that has been adopted by several SDOs and has been deployed in critical infrastructure with several implementations. So it's something that is out there. It is a generic framework defined for highly asymmetric and constrained networks that can work, of course, also on a high throughput networks, because the way I presented it's a low complexity, like compared to something more advanced, right? And it's a stateless compression, right? So it's datagram based. So if you lose one datagram or if you lose 1 million datagrams, well, it doesn't matter. Like it's not going to affect the operation of the whole network. And it is RTT agnostic. So these are really nice properties for interplanetary communications. And just to show why do it, well, depending on the traffic, we can expect gains. So this is like a back of the napkin calculations of the 2 to 10%, like it depends. And the point is that we need to have some more understanding of the traffic that is going to actually be used, we expected over these interplanetary links. And from what I understand, there is an important work from Jörg Ott on getting actually quick traffic, which is going to be like on a simulation of this kind of links. And there is also a work that's going on that has been started on in our working group, SCHC for quick compression. So this tomorrow, like I'm going to try to explain a little bit more on the SCHC technology, and the point is to try to create a bridge and to say, hey, well, if we need to create some work there, I think that I'm out of time. So the point is to really present what we're doing here in SCHC and how SCHC could be applied to these interplanetary communications, and to say, well, there are a lot of things that can be done. Like there's the management, there's something that could be actually specifically fine-tuned in some case to the tip-top traffic. Yes, so Sandra.
Thanks, Sandra Cespedes, Concordia University. I just wanted to highlight that we already have in the group the SCHC over DTN draft, which specifically addresses this kind of scenarios where you have disruptions and very long delays.
Yes.
So we should see also how that fits into the picture with tip-top and IP.
So, okay, yes, that's an excellent question. So we have this, so the first thing is that we need to be very careful about terminology, because DTN in the context of tip-top is understood as bundle protocol. So they are thinking like this. So when we say DTN, it can be like, okay, butane.
No,
so
but the draft specifically says this is for disruption tolerant networks.
Exactly.
It doesn't
Yes.
talk about any specific protocol that solves
Exactly.
the packet forwarding in that scenario. It's just
So that's the message. We should say disruption tolerant protocol. It works on disruption tolerant networks, and that clears out the ambiguity, right?
okay.
So that's the first point, and yes, that will be really interesting to see how the disruption tolerant. So I mentioned it like I'll have 20 minutes there. Now I have like only 5. So I'll talk a little bit about your draft, right? But then also we need to see, like, now the point is just try to make connection to tip-top and say, hey, this is this really interesting framework that can give you these benefits, and we can work on that. There are these works that are ongoing. And then like to do more official work if there is interest from tip-top, right?
Okay, thanks.
Yes. There is someone else on the... Mark? Yes.
Marc Blanchet. Slide 2. Oh, already. Okay.
Slide 2.
Whatever. Fine.
Yes.
So you say packet loss 1%, Mars 1 to 5. So I don't know where you got those, but currently there are essentially no packets traveling in space, only frames.
Okay.
And I think that's appropriate to know for you guys is because it's, it's so important to get, especially the command and control, when they actually send a command to, tilt the antenna for, 1 degree to a Mars orbiter, it needs to be received right. So what they have been, and it's just a small example, but what I'm trying to say here is because of those kinds of use case, they over budget the link budget, with multiple dBs, and they have 2 codecs in the pipeline in the frame layer, frame layer protocols. So when you ask the mission operations people, what's your frame error rate? They say 0. It's like, wait a minute, you're in space and you have 0? They over budget not only the link, the actual signals, but having a pipeline of 2 codecs, and this is back to, the 60s and 70s, it makes 0 loss of the frame. Therefore, there's roughly 0 packet loss. We'll see. But if the frames are not lost, then the packets are so. And given what you're working on, I think that's an important, aspect of the compression, right? What's the loss, right? And what happens when frames or SCHC datagrams are lost?
Yes. So thank you for that clarification. And actually, I was not going to show this particular slide to the tip-top working group. Sure. It was here mostly to remind like what are the interplanetary links, but it is important, this distinction to say, well, technically it's zero, right?
Yeah, nobody can see zero.
From our point of view, zero.
I went Monday morning. I was visiting the Madrid DSN network site, and I had that discussion with the mission guys that are, and the DSN is 3 sites, right? California, Madrid, and Australia, and they follow the sun. So the operations guy here currently during the day are managing the 3 sites. And I asked him specifically, what's your frame rate? He says 0. I said, no. Then says, maybe 1, or it's like, so you cannot say 0, but marginally near 0.
So, okay, we'll need to move on, but that's the point. It's really important when we talk about management later on, like how we design actually the management for us. Like if it's almost zero, it's one thing. So if you can put also the timer, then I'll try to speed up this presentation. So moving on to the next presentation, and this is the concept of chiclets. So a modular approach to SCHC. And basically the objective, like it's the analogy with chiplets when you, like in chip design, and when you want to have some modular functions that you can then easily recreate new chips out of these modular functions, well, to have chiclets. So it's a modular atomic subfunction of SCHC. And let me just show you some examples. So the first thing is, first, initially, I wanted to do something like an informational, or this to be merged with the SCHC architecture in some way. And then with a discussion with Pascal, he said, well, probably you should think about making it a standard track. And then after some work on that, I think that this is the way to go. And this is how I see it, because it's very simple. Actually, it's a very simple concept. So the first definition in the document is the full SCHC implementation. So that's an implementation that covers all mandatory aspects of SCHC as defined in RFC 8724, plus eventually like additional drafts and RFCs that come out of the working group. A full configuration, that is the set of SCHC profiles, parameters, and all that, supported by a full SCHC implementation. Now, the point is that if we have a modular subfunction, that is called a chiclet, it means that you need to be able to interoperate with a full SCHC implementation given a specific configuration. And now there is a very beautiful thing out of that. We can define a chiclet as a piece of software or hardware that can interoperate with a full SCHC implementation under a specific configuration. And that means that if we just say, well, I have a piece of software, it supports this kind of set of configuration, that's my chiclet. And it can interoperate with a full SCHC implementation, and that's it. Now, why is that interesting? Well, it's because it's a much simpler way of looking at the functions of SCHC. If someone wants to use just a subset of SCHC, as was the case for Diet ESP, so this was actually the case that prompted working on that, like they don't need the fragmentation, they don't need a lot of things. It's just a piece of like, okay, I compress these fields in that particular way, right? Then they can do that through a chiclet. And it's fully interoperable with a full SCHC implementation on the other side. And just a couple of examples, a compression chiclet. You can say, well, these are all the compression stuff that SCHC does, that RFC 87, that's one chiclet. And you define the yang of the configuration, and that's it. No ACK fragmentation chiclet. Yes, that's one. You can say, I have a chiclet that is a specific no ACK fragmentation with these particular parameters, where the rule ID is 8 bits, the DTAG size is 0 bits, and so on. So that's a chiclet. I do not support anything else. Like if you come with me with 7-bit rule ID, it will not work. and Aconera and all that. And now there is an example in the draft where actually there is a code for a minimal fixed field compression chiclet. So it's just to say how you can have a super simple chiclet code. So this chiclet basically does almost nothing. So it compresses, when it sees an IPv6 traffic, it compresses like the version, the traffic class, and the flow label. If the traffic class is 0 and the flow label is 0, it compresses that. And anything else is a pass-through, right? And so just to make my life easier to write the C code, like not to shift bits left and right, the rule ID is 1 byte. it can be 1 bit, right? But this is 1 byte. And the 0110 blah, 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 that is the pass-through. And this one is the compression. Like if you look at the pass-through, it is very, very suspicious, exactly the same as an IPv6 header. That is, we know what the. So anyway, it's a clever thing here. So this is the Yang. So this is the configuration in JSON that corresponds that configures that corresponds to that general description. Like there are two rules. There are two rules like 6.0, like the value length, and the first thing is the version, it compresses it with, so it's bidirectional, CDA not sent, so the full configuration is there. And this is the code that implements this. So this is a C code, you can go in the draft, you can compile it. So this is the compressor, and this is the decompressor. And you can run it, right? So I think this chiclet is a concept that can be used to really generalize the use of everything that we've been doing in SCHC without, you know, we can have the SCHC way of doing the things like the full framework with the whole like management and all that. And we can provide ways and tools for everyone that just needs a piece of that, like through chiclets. And we can say just, hey, well, you know, it's formally defined in this way. And if you need to cite it, you can say, well, this is a chiclet in the SCHC framework. Blah. So thank you with that. And I see two hands, if I can have 2 minutes for questions.
Sandra Cespedes, Concordia University. I just wanted to say this is great work because we were dealing with the issues of how to use just a piece of SCHC in the IETF. And a part of that, I think that it will help to have all these flows that some might need compression, some might not. We do have a way in the IETF to mark those traffic flows that won't go through compression. So that will help us just linking with that piece of SCHC-led code that will just go through without any compression. So if we can collaborate to maybe have the IETF as a use case, then that would be great.
Please don't call it a piece of SCHC.
Noted.
Yes, thank you. There was someone, okay, there are some other, yes, go on. Okay.
Sorry, am I in the queue? Okay, yeah. So thanks for the presentation, Alex. Quick question. By the way, I'm Manoj from IMT Atlantic. Okay, so the question is on slide 2. You mentioned about like atomic functions. So can you clarify what do you mean by atomic here exactly? Slide 2.
Maybe the word atomic is not not perfectly, but it's basically something you can take out and it can live on its own. Like it doesn't. If you do a compression, a specific compression of something, like you don't need something else out of it, right? Out of this. Like for example, if you have a CDA,
Right.
MSB, for example, also LSB, then like it works on its own. It doesn't. Maybe autonomous. Yes, it should be an autonomous.
Okay.
Yes.
Got it. Thanks.
Thank you very much for that. Laurent, there is maybe a question or no? Who is in the queue? Laurent. Okay, but he was maybe very fast because. Okay. Go ahead, Alejandro. Very short.
Okay, so very quick. Alejandro from IMT Atlantic. Okay. So my question is, if there is some sort of capabilities list or definition, like how do we ensure that since it's supposed to be compatible with a full SCHC implementation, how do we ensure that we don't like start to try to interact with functions outside of the chiclet scope?
So the point is that the very definition of the chiclet will be the configuration that chiclet supports. So you push that to the full SCHC configuration, to the full SCHC, to the full SCHC compressor, and to the full SCHC implementation, and then that full SCHC implementation will be able to interoperate because it only uses this subset of the configuration, right? So. Okay. So what do we do? Do we call the Laurent? Okay, there is another. Just Laurent. You for the presentation?
Okay, so I have 5 minutes to talk about seed allocation, so I will go very, very quickly. There is more slide to understand the context, but the good news is that now we have our values. So we have a range for our young data model that is defined by RFC 9363 and is just under the time meters, so you cannot read it here. But it's 2,550, and we have 400 value, which is a good range to do allocation. So we do allocation, we can do it automatically using the Pyong data model and the Pyong tool. And this way we can have, for example, for a very simple rule, we can have this representation that is very, very compact. But if we don't go to the automatic tools of Pyong and we do some more clever things, then we can be more efficient. One thing is that if you look at the allocation, we have things that value or deltas that are larger than 23, which means that they need 2 bytes in CBOR to be coded. So if we can arrange a delta more in a more clever fashion, then we can have a more compact model. So what we propose is not to allocate linearly things, but using the hierarchy of Young and do jump of 23, because that's the larger values and we can code in 1 byte. And this way, we can leave rooms for revision of the Young data model, which means that the new delta can be also in a very short range, or short delta, and so we can have something quite efficient. So here in the example, we save 7 bits just by changing the allocation in a very, very simple rules. So the question to the group, and that's what I will have to as a discussion. So right now we have another draft that is the universal options that will obsolete the co-op options that we have defined in 8824. And so do we allocate seeds for the function, the value that we know we are going to obsolete in the near future? Because when you allocate a seed, it's forever until the end of humanity. So it's stupid for a few months to lose this value. So that's the first question. Second thing, I think we have to start a revision of the data model because we have new things to include into the data model. And then we can allocate these seeds on the new data model. So it includes universal option. It includes also the revision of the RFC on co-op, component acknowledgement, and ICMP v6. And so what I would like to have is a double check of what we have done, because it's no more automatic tools, but it's allocate manually. So maybe we can introduce mistake. So and this mistake will last forever. So it's very important to review the current seed allocation we have made, and then we can send it to Viana. So if you have questions or remarks.
So a very short remark about the allocating a seed to something that will be obsolete. Do you have examples of implementations that use the option today that will be obsoleted in the future?
You have OpenShift, but I think it's not a problem because I don't think, except if someone raises his hand, that use this value right now for operational things. Okay, so these are the ones we will not allocate.
Laurent, I was wondering if there is a way to allocate experimental seeds just to be able to code between ourselves as long as our model is not stable, and then move the implementation to, because it's not deployed in the field, right? It's mostly people need a seed to implement. But is there a way to just have our own base of experimental seeds?
So there is experimental seed that we can allocate. Here, all the identifiers are not delta encoded. So we can
It's just
put
to
them
experiment till
everywhere.
our model is stable, right?
Yeah.
In which case you won't even have the question of allocated temporary seats, because by the time we allocate real seats, it's going to be gone.
Okay. So I have only 20 seconds here. So, so the other thing is about core conf management. So I will not go into details. We have discussed that during the last interim meeting. I just want to give you an overview of the discussion on the direction we want to go. So for this, as you know, we have currently an instance that share the same set of rules, and that's the basic of SCHC. But what we want to do is to make this set of rules evolve the same way on both sides, and to add new rules or delete new rules. But we don't change the compression mechanism. We just add some way to manage the set of rules. So regarding the architecture, is what you have on the upper side. It means that we introduce a new category or new nature of rules that are the management rules, that are in fact compression decompression rules, but are dedicated to the management. And we dedicate to this also an IP stack that will never interact with the rest of the system. So this way we can have a very simple environment where we can allocate 2 IP address to both ends, 2 port number to both ends, which means that we can have a very efficient compression of things. So in the RFC, we define 2 compression rules that will compress the full stack in very small values, because we just have a matching list for the code, and we send a part of the message ID for the co-op. So we say that we don't use tokens, for example, in the co-op, because since we are doing management, we have immediate response to the management, so tokens are not useful in that case. So it means that we can have something very simple to do the management, but are compatible with the IP stack. And it's now the jobs to be done is also to include encryption, because maybe we have to secure this. So what we discussed also in the group is that if we modify a rule, it can be very complex, because if we have some packets that are delayed in the network, so it will be sent using a rule ID, and if the rule ID is changed in the middle and then the packet arrives, then the rule ID will be different and the compression will not be good. So we have to avoid that. One way will be to use a guard period before accepting the new rules. But I think it seems to have a consensus during the entire meeting, is to say that we cannot modify a rule. We can just create a new rule with a new rule ID. So this way we avoid the confusion. And we can have also, as in the yellow figure, you can have an implicit acknowledgement. For example, if you lose the acknowledgement, the fact that the other side is using this new rule number means that I receive it, and we have a kind of explicit acknowledgement. So it can optimize things. So here we are doing fetch and IPatch. So we have a lot of examples in the document, so it's quite interesting. And what we propose to do, in fact, is not to use always post and IPatch, but in fact to use RPC that will say I'm duplicating the rule. So from this rule, you make a copy to this rule ID, and we can add an IPatch sequence to modify some things in some value in the rule. So this way it can be done in one RTT, and so it can be efficient for underwater communication where RTT is very big, or Alex says in space communication where we have also long RTTs. So it gives here an overview of what we can do during management. I will skip that. We have also something on error management, but I have no time to discuss on this. So you have a draft that includes a lot of examples. You have also an implementation that works between OpenSCHC and MicroSCHC. So you can test it. Manoj?
Thank you for the presentation, Laurent. On slide 5, you talk about various ways to modify a rule. I was wondering if you thought about adding a notion of TTL to a particular rule ID, so you don't have to have immutable rules. No, I think, sorry, the one before that. Yeah, this one. So you don't have to have immutable rules, but what you can have is a rule with a TTL, and after a specific time, you can just modify the rule, and everyone knows, everyone expects the rules to be changed. If the rules are not going to be changed, just have the same rule with a different TTL.
So I don't like TTL because it means that we have synchronization and it can be quite complex to manage. Here it's, for example, the guard parameter is something that you know the desequencing in your network. So you say, you put that in the rule and I say the guard, if you have no desequencing, you have no guard. If you are, you know that you have 1 or 2 packets of desequencing, you put this, this value. So it's something that will be very specific to one environment. But honestly, I prefer to avoid ambiguities and play with rule IDs, and it will simplify a lot of things.
Okay, we can take this discussion offline. Thanks.
Okay, we really need to move on. So, I mean, now it's going to be you this time.
So while we're setting up, Marco, I'm benefiting from the time that you're here. That, you know, I mean, CoreConf we're depending on CoreConf, just to know if you have any opinion or any vision of when we can get ComI and CoreConf move to the next steps in Core.
Yeah, Marco here. CoreConf is actually a cluster of 4, now 5 documents, but 2 were published as RFC already. Yeah, the next in the queue, I hope can be completed.
About ComI, so you can come and hit me with a stick to finish it if it's necessary.
Hello everyone, my name is Amina Mouqdad. I am a PhD student at IMT Atlantic in Rennes, France. Today I will be presenting my research work. We focus on integrating the SCHC protocol into 5G networks. This presentation will cover SCHC entities placements over the 5G, and then we pass to the SCHC parameters configuration and adapt it to 5G networks, including SCHC signaling over 5G and the device identification. And we will finish with the SCHC packet handling over the 5G. So let's start with the brief reminder of 5G architecture and data transmission. So this figure illustrates the 5G architecture, where we have the UE, which is the device capable to connect to 5G networks, the G-Node B, which is the 5G base station, and the 5G core networks, which contain various network functions working together to provide network services. A key function called the UPF, which stands for user plane function. It is responsible of routing and forwarding the user data between the UE and the data network. When it comes to data transmission in 5G, 2 paths for data are specified. The first one is the usual one, which is the data in the user plane. And the second one, it's used for IoT use case, which is the data over the control plane. We send the data over the signaling messages. So deploying the SCHC entities over 5G requires placing them between the UE and the data network. The first endpoint, which is obviously the UE, the device. The second endpoint, we propose to use the UPF. We introduce a modified UPF called SUPF, stand for SCHC UPF, which is capable of handling SCHC compression and decompression by redirecting the packet, the SCHC packet, to SCHC compression and decompression unit. But it still functions like a like a standard UPF. Why UPF? UPF, it is the intersection point between the 2 paths of the data, and in case of mobile devices, we don't have to exchange the context during mobility. Moving now to SCHC parameters, starting with the SCHC signaling over 5G. So how the device will spread the information that it is using SCHC to the network, and the network inform the device that request is accepted. We went through the signaling messages, the 5G signaling messages, specifically the messages that contain the UE, the device capabilities and the network capabilities. During the registration procedure and the PDU session establishment procedure, we find out that we can add this information within the messages illustrated in the figures. For registration, we have, for example, 5GMM capability, which introduces the UE capability to the network during the registration procedure. We can add the information of SCHC is activated for this device in this message, and it's the same for the rest of messages. Unfortunately, I don't have time for explaining all of them. So for the device identifier, we have in the network, we will have many devices and one SCHC compression decompression unit, which will manage all the context, all the set of rules for each device. So we need an identifier to do the correspondence between the device and the context. In 5G, there is multiple identifiers, but most of them can change by the end of the device connection session. That's why we propose to use the PEI, which is stand for Permanent Equipment Identifier. This PEI is sent to the SUPF within the, or the UPF, same, within the user ID information element during the PFCP session establishment request. So we don't have to introduce new methods to send this PEI, this identifier, to the SPF. It will be already sent, it will be sent within the messages. Now, I will take an example of an uplink transmission of a SCHC packet in 5G. So we have a UE, which will compress the packet, as illustrated, here. So we have rule ID and residue. This packet will be sent to the SUPF over the G-Node B. The SUPF will retrieve the PEI, which is the identifier, and the packet, and send it to the SCHC decompressor, because here we have to decompress the packet. The SCHC decompressor will decompress the packet using, first retrieve the context of the device using the PEI, and then find the rule using the rule ID. The packet then is sent back to the SUPF, which will act like standard UPF. Here, these steps are the steps performed by standard UPF. Then the SUPF will send the packet to the data network, which is an IP, will send the IP packet to the data network. So there will be no conflict between the UE and the final destination of the packet. Like it guarantees full IP connectivity. Thank you for your attention. By the way, you can find more details of this solution in this reference, and also there is a draft which is not full. There is not a lot of information, but it will be updated as soon as possible. Thank you so much. If you have any question, I will be happy to ask. No question. Oh my God. Okay.
There's a question.
Hello, my name is Poonam. I'm from University of York. Nice work. Thank you for your presentation.
Thank you.
So I have one question. How do you see this will fit into the next generation architecture, for example, ORAN architecture or 6G architecture? Because right now you're doing most of the work from a UE to G-Node B to core network functions, but the new architectures are bringing together a totally different, it goes through ORAN, if you particularly consider ORAN architecture.
Yeah, actually here, there was no question, then there was one. Actually, that's why we choose the UPF, to avoid, in case of modification in the stage of the G-Node B, for example, or something like that, we won't have to change anything, just the SUPF, which will handle the compression and decompression procedures.
Okay, maybe I'll follow up later.
We don't have time. I'm really sorry. But I will be happy to discuss that with you after the session. Yeah. Thank you so much.
So I think that is the fastest presentation of the 3GPP technology we'll ever see. I hope you managed to get all the abbreviations in your head, you know.
Okay.
Can change the slide.
All right, good afternoon again. My name is Manoj. I'm a PhD student from IMT Atlantic. I'm the last hurdle between you and lunch, so I'm trying to be quick.
You have 4 minutes, I'm sorry.
Okay, I'll run through some of them, but let's see. Okay, so there are two parts to the talk. One is why. Why do we apply SCHC to geo-networking? The second part is how. What is the best way to apply it? And this is where I think I need your contribution. So the problem which we are trying to solve is there are cars, they send periodic autonomous messages. Sorry, autonomous cars sending periodic messages called as CAMs. These particularly contain safety and kinematic information like acceleration, velocity, etc. They are periodic, as I said, and they are emitted about 10 hertz, as in like every message per 0.1 second. And usually they operate on IEEE 802.11p or dedicated short range network or DSRC. Okay. So how are we solving? So it's a very simple application right now. What we do is we install SCHC context on one of these semi-autonomous or autonomous vehicles. And the other vehicles have the same, and they transmit the compressed messages and they decompress it on the other vehicles. Okay, so this is how the message looks like. We have CAM, the cooperative awareness messages at the top. Then there is it's called basic transport protocol or BTBB. And then there is geo-networking, right? So this protocol is what we are trying to compress. The whole message is typically about 100 to 113 bytes, but in that geo-networking has about 40 bytes. So it's a bit of a bulky protocol which we need to compress. This is how geo-networking looks like. In fact, even if I had 50 minutes, I wouldn't go through all of it. But there are 3 parts to it, geo-networking protocol. And what we do is for each of these subheaders and fields, we decide either we can elide them, like don't send them at all, send them partially using some of the operators, or send them completely because we cannot compress them. So the way we have modeled is we have made it the SCHC application into 2 rules, like conservative and aggressive. In conservative, what we do is we elide or we try to omit information being sent so that most of the cars can actually make sense of it. These rules, the conservative rule, can be installed in all the cars regardless of region, right? You can put it everywhere. The aggressive ones are more context specific, as in like context or scenario specific, right? So these rules are like particular to a region of vehicles. And this might allow more compression, but it means that it's stuck to, or like it's bounded to a specific region. Quick example for geo-networking conservative rule, it's for example, geo-networking version. Now this version hasn't changed since ever. So what we can do is we can simply elide it, and this rule can be installed in all the cars. For aggressive, what we can do is like something very specific. This particular platoon of cars doesn't move beyond continent within a fraction of seconds. So what we can say is we don't need to send the complete 32 bits of latitude information. What we can just do is send the last 15 bits where the real information is. Okay, so we've been talking, we know that SCHC works, but for the first time we can actually see how well it works. The first graph you see is uncompressed CAM message using spectrum analyzer. So it's being omitted by a box called as Yogoku, which is a onboard unit. So we see about like 70 byte uncompressed takes about 190 microsecond. If we apply a conservative, it takes 172, and aggressive is about 165 microseconds. So about 13% less. Another quick evaluation, what we care about is how the network performs under load with compression, right? So I won't go into the detail of the graph because we don't have time, but we see about like the channel busy ratio, which is a proxy to to measure channel congestion. We see about the congestion is reduced about 14% with various data rates and various transmission power. Now, what I need your contribution is, there is a lot of argument about the SCHC architecture, right? So SCHC works really well for point-to-point, but for broadcast, say point-to-multipoint or multipoint-to-multipoint, that is where I think we still, at least for me, it's not clear how to do it properly. The definition of optimal rules, based on how we define optimality, is very interesting problem to solve as well. And I think I would also talk about the one of the architecture issues. Assume there is a platoon 1 on the left side, and then there is a platoon 2 on the left, on the right side, and these platoons are operating independently, autonomously, and then they decide to merge. How do we build consensus for SCHC rules? Who should get the say, and who shouldn't? So, yeah, these are some of the problems. Yeah, and this is a bit of a. I mean, I want to ask the community here, like. We work on SCHC a lot, and but I feel like the simulations are a bit missing. The only one I could find is from February 24, 2019, from WILE. And if there is anyone building a better simulation or wants to build a better simulator, I'll be up for it. So that's about it. Thank you.
One quick question now.
One quick question now. So we are exactly at the time. I wanted to show something. So we're not going to have time to really for you to present it, Mariam, but I just wanted to bring your attention to that great work. So it's actually a scientific paper. You have the reference there, and it is like SCHC 0, like static context with enables zero-touch IP-based onboarding from device networks. So please come and talk to the authors, Mariam, and the authors. They are here in front, and it compresses Brusky, and yeah. So actually, I did the pitch. Sorry, I hope I didn't make any mistake. So I think it's a very interesting work to follow. Yeah.
And with this, we thank you all for your attendance in this meeting. So that's the end for today. So your blue sheet was automatically recorded if you used the online tool. If you did not, please look at the code, the QR code at the egress of the room. You can still register, but yes, make sure you're on the blue sheets.
Thank you, and see you in Montreal.
And we need to leave the room quickly because something is coming.